Hi, and welcome back to this section, Functions that work with iterators. Now, what are we going to learn in this section? First, we're going to take a look at several convenience functions such as zip, map, enumerate, and filter, which are functions that are by default built into Python and that you will use quite often when working with iterators. We will then move on to another set of functions for numerical and logical operations on iterators, functions such as any, all, min, max, and sum. So those are functions that you will use mostly when you're working with iterators of Boolean values, so true, false values, or iterators of numbers. Then we'll take a look at the Itertools module, which is a really convenient module for working with iterators. It provides a lot of very convenient functions. And we're also going to take a look at the Functools module, which again contains a lot of very convenient functions, but now mostly for working with higher order functions, a concept that we'll introduce also in that video. And the Functools module is also very focused on working with iterators. And finally, we'll take a look at an example. And this example is going to be an interactive calculator that we have built with iterators and a lot of the techniques that we've learned during this volume. But let's start with the video using convenience function. Python has several built-in functions, so that meaning that you can use them right away without having to import anything. Several built-in functions for working with iterators. And here we're going to take a look at some of them: zip, map, enumerate, and filter. And we'll also take, where this is applicable, take a look at how these functions compare to list comprehensions and generator expressions, so that we'll have a more concrete idea of how these functions work. Now let's take a look at how we can use these functions in real Python code, and we're going to start with the zip function. So we have predefined lists. We have the species list, which contains a whale, a lizard, and an ant, and a class list, a mammal, reptile, and insect. Right? And these lists are related to each other in the sense that the whale is a mammal, the lizard is a reptile, and the ant is an insect. And then we have a list of cuteness ratings, 3, 2, 1, and 0. And this is also somewhat related to the other classes, namely that the whale gets a cuteness rating of 3, so it's the cutest of all. Still not very cute, I think, by mammal standards, but cuter than a lizard, which has a rating of 2, and cuter than an ant, which has a rating of 1. And then you see that we have this extraneous 0, right? So the cuteness list actually has one value too many, and we will see how zip deals with that. To start with, we want to map a species to a class. Then we can do this as follows, and we're not going to use zip. Right, so we should say for I in range length species list. So we would create a counter variable, right, I, an index, and we're going to use this index to get a species, okay, species list, I, and also a class. I'm suffixing an underscore to indicate that it's not a special keyword, class list, also I. And then I would say, okay, print is a. Okay, right? And then if I run this, you will see that we get what we expect. A whale is a mammal, a lizard is a reptile, and an ant is an insect. This works in principle, but I think that this construction of using first getting a length of a list and then making a range based on this length and having this counter of this index variable is really ugly, right? It is not very pretty, attractive, aesthetically pleasing Python code. It works, but it's not very nice. That's where the zip function comes in. Because if we want to do the same thing with zip, it suddenly becomes very easy and very elegant, because we can simply say for species, comma class in zip species list, comma class list, and that's it. And then we can say print is a species, comma class. So you see that our looping through these two lists at the same time is very easy, right? So what zip does, basically, it pairs the first item from all the lists and returns that as an iterator or as a tuple. Here's a species, comma class. Then the second pair, then the third pair, right? So we get essentially tuples for each index in the lists that we're looping through. And that is a situation that you will encounter very often, so it is very elegant. Now here we're doing it with 2 values, 2 lists, but we can also do it with 3. So say that we want to get the cuteness in the mix. Then we can say, okay, cuteness list, and then we can add it. Here we say something is a something and has a cuteness rating of. And if I run this, you see that it works. Whale is a mammal and has a cuteness rating of 3, etc, etc. You also see the behavior of zip, that it takes the shortest list as a starting point, right? So you see that the cuteness list actually has 4 items, the species and class lists have 3 items, and if we zip them together, we end up with 3 tuples that pair these things, right? So the last, essentially this 0, is discarded because the cuteness list is too long. So that's how zip works. It's very simple. Once you've started using it, you will find yourself using it all the time. Now, then we have another function that is very convenient, and that is actually a programming function, or a function that comes from the style of functional programming. And it's called map. And map applies a function to each element from an iterator. Now say that we have from math in sqrt, right? So we have a function that calculates the square root, and we have a series of Fibonacci numbers, and it's 1, 1, 2, 3, 5, 8. And what we want to do is apply the square root to each Fibonacci number. So how can we do that? Well, we can do that very sweetly with map by basically saying for I in, and then I say map. Then the first argument is the function that we want to map onto the iterator, so the square root in this case. And the second argument is the iterator that we want to map onto, which is Fibonacci. And then I say print I. And now you see that we get, for each element in the Fibonacci list, we apply the square root function, and that's what we then iterate through. So that's a very sweet way to essentially transform all the elements of an iterator with one sweet function. We can also accomplish this in a generator expression, and I would say in this particular case, this generator expression is not as easy to read as the map function, so I wouldn't use it. But just to give you some training of how generator expressions work, let's take a look at how that works. So we can say for I in, and then between these parentheses is going to go a generator expression. I'll leave it empty for now. Print I. Now, what is the generator expression that's going here? Well, we're going to take the square root of something. Let's call that something j. What is j? Well, for j in Fibonacci. Right, so we create a generator expression, and what that generator expression does is apply square root to each element of the iterator. And you will see that it works. It's completely equivalent to the map function, but I think in this particular case, map is simply semantically cleaner, right? It is much easier to read, so I would recommend using map whenever this is possible. But it doesn't do anything magical that you couldn't also do with the generator expression. Then we have the enumerate function, and enumerate is extremely convenient because it gets you indices along with elements of an iterator. Say that we want to get the indices of our species, and we want to do that without enumerate. Then we would create first an index variable, and then we would say something like for species in species list, and then I would say print I species, and then I would increment I by 1. Right, so whale would be species 0, lizard would be species 1, and ant would be species 2. This works, there's nothing inherently wrong with it, but I think it's very inelegant that we create this counter variable I, right? This scenario is very, very common. You will very often run into it. Maybe you will now notice we've seen a zip function. What you could also do is basically zip species list together with the range function. If you would want to do that, that would be already slightly better. I will not show that here, but instead, the best solution is to use enumerate. And enumerate simply goes like this. I say for I, species in enumerate species list, and then I say print I, species. And you see we get the exact same result, but it's much sweeter and we don't have this extraneous counter variable. Well, we have it, right? I still exists, but it is created automatically by enumerate. And I think this is a very readable, very syntactically, semantically sweet way to do this, right? So use enumerate whenever you can. Can we have an equivalent generator expression to enumerate? Yes, we can. But again, I would say it is so complicated that I wouldn't necessarily recommend using it, but it can be insightful to nevertheless take a look at it. So say for I, species in, and then here's going to be our generator expression. I'll leave it empty for now. Print I, species. So what does our generator expression have to return? Well, I is going to be our index, species list I, so we're going to get from the species list the species at position I. For I in range length species list. Right? So you see the logic here? We create a counter variable I that loops through all the indices in the list, then returns the index and also gets the species at a particular index. If I run it, I get an invalid syntax for I. Oh right, because I need to put parentheses around this. And you see, again, it does exactly the same thing. I think this is an interesting example of a generator expression, a pretty complicated one, and clearly the enumerate solution is much better, right? I'm just illustrating the generator for educational purposes. Let's then move on to another very convenient function, filter. And like map, filter is one of these functions that comes from the functional programming tradition. So functional programming often uses a combination of map and filter. And what filter does is it excludes elements. So say that we have our Fibonacci series, right? We still have that one. It's 1, 1, 2, 3, 5, 8. Say that we want to get only the even Fibonacci number. How can we do that? Well, we could do something like this. We could say, okay, for I in Fibonacci. And then I would say if I modulo 2, continue. In other words, if I modulo 2 it gives something, then it is an odd number and we're going to ignore it. We're going to continue. Else, print I. This works, right? And we get 2 and 8, which are the only two even numbers in our Fibonacci series. But this is not terribly elegant. Can we do better? Yes, we can. We can use the filter function. So the filter would work as such. We say for I in filter, And then the first thing that we need to pass is a function that does the actual filtering. And it's going to be this. It's going to be a lambda function, a lambda expression, which takes a number and it checks not I modulo 2. In other words, it checks whether it's even, whether I is even. And then we pass the iterator that needs to be filtered, which is Fibonacci. And then we print it out, print I, and we also get 2 and 8. Right, so filter is pretty sweet. It first takes a filtering function, which should return true for all the elements that are preserved, and then it takes an iterator to be filtered. That's pretty nice. We can do the same with the generator expression. So what we can do is for I in j, for j in Fibonacci, if not j modulo 2, print I. And it does again the same thing. Here what we're doing is, and we've seen that before in previous videos, we're using the fact that generator expressions can take an if clause, and we're using this if clause to exclude all the elements that are odd, or include only the elements that are even in our generator expression. Right? But again, I think you will agree with me that filter is in this particular situation a nicer solution. But in other situations, I have to say that using a generator expression or a list comprehension in combination with the if clause that we're seeing here can be semantically cleaner. Right? So I think depending on the situation, you would do that or you would use the filter function.